Happy Holi to all. It's a Holi and COVID, so there are restrictions, but I hope COVID is not damping the spirits and everybody is having some fun with the colors. It's hot as hell outside as well, but the next micro podcast on our list is Micro-Wind, exactly what it says, little wind turbines which can be put on top of houses, buildings in your backyard, reduce the eyesore of the big windmills, reduce the noise. Efficiency is low, around 25% usually, but the way I would suggest thinking about it is the leaves on trees, for example, or the phytoplankton in the ocean. They harvest light at an efficiency of 2 to 5%, which is very low, but the number of solar cells in terms of leaves is so large that they can support the entire food chain on the planet, right? So this is how one would think of. Of course, you cannot put billions of micro-wind turbines. We will have to worry about what that would mean for circulation and so on as well. Nonetheless, this ranks at number 76 with a reduced CO2 of 0.2 gigatons, which is modest, but the value of giving people energy freedom, reducing energy poverty cannot be put in monetary terms. The net cost, which is not always easy for poor people to afford, is $36.1 billion. $36.1 billion, and the net savings is almost $20 billion. Just to get a sense, here is a micro wind on top of a house, basically attached to the roof, so it can manage the wind strength that is expected in this region, along with these antennas for Wi-Fi and TV and so on. So can be order 1 kilowatt, which can be quite useful for people to stay off-grid on some occasions, or they can be also put on these cell phone towers to provide additional energy to run some of the systems. They are much less noisy, especially the one shown here, which is from Vision AR5 vertical axis wind turbine. It's quieter than human whisper at low wind speeds. Of course, that's low wind speeds, which means also low energy. The turbine is 10.5 feet high and is rated at 3.2 kilowatts of power. The minimum wind speed required is 9 miles per hour, and it can withstand speeds up to 110 miles per hour, so can withstand a cyclone if necessary and installed properly. So obviously can generate decent amount of power if you assume that each house is consuming about 1 kilowatt per day, but that's for a rich country. It will be much lower for developing countries and for people who live in modest housing or in rural areas and so on and so forth. So micro-wind is a good part of the solution, especially in terms of reducing energy poverty and giving energy freedom to the poor people. Increase micro-wind fivefold to 1% of global electricity generation by 2050, and it can deliver 0.2 gigatons of emissions reductions. Like in-stream hydro, micro-wind turbines allow for extension of clean, renewable electricity in areas without grid access. So this can allow developing countries to tide over the people who are not on the grid and who are not close to a grid or not have the wired-in electricity yet. These can serve as good transitions till full power is made available, and it can be also a good way to run most of the simple systems, lights for kids to study at home, or little refrigeration system for saving milk, or vegetables for farmers, fruits, etc. Because when you are wanting to produce cash crops like vegetables or fruits, and you are away from the peri-urban or urban regions, and you don't have refrigeration, getting rid of them can create lots of other economic problems for farmers. So these can serve very well for managing those little systems. Okay.